Unlike scripts, which are saved outside your database as text files, stored procedures are saved as objects inside your database. You can execute a stored procedure from a client application, a batch or a script, or from other stored procedures. Stored procedures are parsed and syntax checked when you create them and are compiled on first execution, and I'll be talking more about that compilation process. Because SQL Server then caches the execution plan and shares it among all users of the database. And then subsequent calls to the stored procedures can reuse that cached plan, even if different users call the stored procedure. Now, this compilation, caching, and sharing of execution plans gives stored procedures a significant performance advantage over running ad hoc transact SQL statements. You can also lock down the security of your database by revoking permissions on database objects and only granting access to data and objects through a stored procedure. That's a significant benefit of stored procedures. You can have a much more secure database. Unlike views, which are also saved as database objects, stored procedures support the full capabilities of Transact SQL. A single stored procedure can contain up to 250 megabytes of text. But that's a limit that you won't encounter anytime soon, or if you do, you should seriously consider refactoring your code. Stored procedures can accept input parameters and can return more than one result set, and they can also return data in the form of output parameters, as well as a return value. Stored procedures are as close as you can come to functions or methods that you find in full-featured object-oriented programming languages. In fact, SQL Server uses stored procedures in most of its internal operations. System stored procedures have a schema name of sys and an SP underscore prefix. You can read the Transact SQL definitions of most of these system stored procedures by running the SP help text system stored procedure and supplying the name of the stored procedure that you want to examine. If you do that, you'll find that most contain explanatory comments as well as the code. And exploring system stored procedures is a great way to learn advanced Transact SQL programming techniques once you've mastered the basics, because you can really see how you can make use of all of the different objects that are available, at least the ones that Microsoft makes available, within a database and an instance of SQL Server. The only tasks that you can't complete with a stored procedure are the creation of triggers, defaults, rules, and other stored procedures, as well as views. So you can't create a stored procedure that creates those other objects. But a stored procedure can do everything from executing a basic select statement to enforcing complex business logic and explicit transactions, as well as modifying data and other database and system objects. So there's a lot of things that you can do with stored procedures. Now, to understand why stored procedures are faster than direct SQL commands, you need to understand how SQL Server processes the commands that it receives. When you submit any command for SQL Server to execute, it goes through several generalized stages. First, SQL Server parses the command for syntax and rejects any commands that are syntactically incorrect. So you're protected right up front. Then, SQL Server translates the command into an internal format that's known as a sequence tree or a query tree. Third, SQL Server optimizes the command based on estimated performance costs and generates an execution plan from the sequence tree that contains all the necessary steps to check constraints and carry out the command, whatever you're doing within the stored procedure. And then finally, SQL Server executes the command. So there's a lot of setup that it has to do before it can actually execute it the very first time. Now, if you send direct SQL statements one at a time from your application, each single statement you send requires all 4 stages of processing. But for a stored procedure, stages 1 and 2 happen only once, when you initially create and save the stored procedure, or you modify it. Then, step 3 occurs only if the execution plan is not already in the memory cache. And then subsequent executions only need to perform step 4, which is the actual execution of the code. The savings from not having to process all of these steps every single time you execute a stored procedure can be an enormous boost to performance. Okay, now there is one issue you need to understand. When you create and save a stored procedure, SQL Server first checks the syntax, as I mentioned. If the syntax is valid, SQL Server attempts to resolve object and column names, which means that it checks whether these objects exist. If the object exists, but the column doesn't, SQL Server generates an error. If the object doesn't exist, then SQL Server defers checking until runtime. So this is called deferred name resolution, and it makes it easier to write complex code because you don't necessarily have to create objects before you write the code that uses them. You won't, though, have the benefit of IntelliSense in Management Studio and the various designers until the objects exist. And as a practical matter, even with the improvements in SQL Server 2012, IntelliSense can be kind of flaky in terms of picking up new objects that are available. So it may take a while before it sees that you've created a new object. So you may get red squiggly lines even though that object exists. So be aware of deferred name resolution. You can write code against non-existent objects. All right, a little bit more about the execution plans. When a stored procedure executes the very first time, SQL Server generates an execution plan. This is what resources it's going to use, what indexes it's going to use in order to perform all of the steps defined within the stored procedure. And it's that execution plan that it can reuse on subsequent executions of that stored procedure. Then, whenever the stored procedure executes after it is initially created, then SQL Server reuses the existing execution plan if it's still in memory. If it's no longer in memory, then SQL Server creates a new execution plan. And execution plans are based on several different pieces of information that SQL Server gathers from the database and server instance. The first is the amount of data in the tables. Second is the indexes and the distribution of data in the indexed columns, whether or not it's able to use a particular index, whether a specific index has enough information stored in order to enhance the performance of the stored procedure. Then it also looks at comparison operators and values used in any where clauses. And then the presence of joins, group bys, order bys, and union clauses. So compiling and caching stored procedure execution plans enables much more dynamic optimization of stored procedures than if the plans were saved when the stored procedure was created. A saved plan would quickly become obsolete as the distribution of data and database statistics change over time. As applications establish patterns of data usage that SQL Server can examine in order to optimize code execution. There's some very sophisticated analyses going on behind the scenes so that SQL Server can execute this code as efficiently as possible. Now, once you have a plan in place, it doesn't mean that that plan is going to be what SQL Server uses for that stored procedure forevermore. There are certain conditions that cause SQL Server to compile a new execution plan for an existing stored procedure. Might be because a copy of the plan isn't in memory yet. Okay, so that's logical. It doesn't exist in memory, so it recompiles the plan to make sure that it's still valid. Maybe you drop one of the indexes on a table, so it has to come up with a new plan for executing the stored procedure. When statistics are updated, this is the statistical information that identifies the particular data usage patterns of your code and applications. If you modify a table using an alter table statement, if you execute the SP recompile system stored procedure on one of the tables, or if the stored procedure was created using the with recompile option. This is a pretty aggressive option because it tells SQL Server to create a fresh execution plan on every invocation. Definitely not something that you want to use without very good reason, because you're eliminating a large part of the performance benefit of using stored procedures. Now, if the stored procedure doesn't run for a while, the plan is going to be flushed from the memory cache. And the next time the stored procedure is called, SQL Server creates a fresh plan based on the latest statistics. This ability of SQL Server to recompile stored procedure plans is a really good thing. An obsolete or inefficient plan is worse than no plan at all. So this is a good thing. So SQL Server performs statement-level recompilation of stored procedures. What this means is that when SQL Server recompiles stored procedures, only the statement that caused the recompilation is compiled, rather than the entire procedure. As a result, SQL Server uses the parameter values as they exist in the recompiled statement when regenerating a query plan. And those values may differ from those that were originally passed into the procedure. Now, a note about using schema qualifiers. When you create and call stored procedures, you should always use the schema name. And that looks like this. So you create procedure, schema name dot procedure name, and then when you execute it, execute schema name dot procedure name. Don't reference just the stored procedure name alone. The reason is that this provides performance benefits. SQL Server doesn't have to resolve the schema name when you explicitly specify the schema. So SQL Server doesn't have to take the time to find which schema the procedure belongs to and resolve conflicting names. Because if the schema is not specified in the code that invokes the stored procedure or other code, then SQL Server first attempts to resolve the schema in a specific order. First, it looks at the sys schema of the current database. This is essentially looking for any system stored procedures within the database. Then it looks at the caller's default schema. And then it looks at the outer schema of the containing stored procedure if this is being invoked from another stored procedure. Then finally, it looks at the DBO schema, the database owner schema. Part of the compilation process entails placing compile locks on the stored procedure because the procedure cache can contain only one copy at a time. If the schema isn't explicitly named, multiple processes could block each other as one process tries to acquire an exclusive compilation lock while SQL Server attempts to resolve the schema for another process. This is generally not going to be a huge problem, but if your database has a lot of different applications that are hitting it hard using the same stored procedure and you don't use the schema name, it can definitely be a drag on performance, and there can be some blocking issues. So the moral is to always use the schema qualifier, even if it's the DBO. If you use no other custom schemas, everything is DBO, which is generally not a good idea, but that's a whole separate topic. Then specify DBO, even though there's no stored procedure with the same name in different schemas. You're just going to have much better performance overall. So let's talk about reasons to use stored procedures. This is a running religious debate about whether or not stored procedures are a good idea, particularly as more applications use tools like Entity Framework, which essentially create dynamic SQL statements at the application level and then hit SQL Server instances or any database instances with these fresh dynamic queries. So why would you want to use stored procedures and then build, for example, an Entity Framework model around the stored procedures rather than creating dynamic statements? Okay, I've talked about one, which is performance, but there are some other good reasons. One is that stored procedures result in a reduced utilization of network bandwidth. Because stored procedures can optimize data access by returning limited result sets. You can prevent users from executing queries that choke the server or the network by returning millions of large rows of data. Instead, you can write stored procedures that filter the data based on parameters that you can pass to the stored procedure. And then you can handle errors at the server within the stored procedure code and not at the client. And often this is a good thing. You might still raise an exception that is returned to the client, but you can also attempt to handle errors, do something about them. Maybe an object doesn't exist, you have to cut off and create an object before the stored procedure can execute. Rather than getting an error at the client level, you can handle the error at the stored procedure level. A big benefit is that you can remove security permissions from the underlying tables. And this prevents users from directly accessing tables and other objects. And this gives you very granular control over access to data, which enhances data and server security. Definitely a big benefit of stored procedures. Another benefit is that you can write stored procedures once and then access them from many client applications, which eliminates redundant code that's scattered throughout many different applications. Because if you change a table, change a schema, add a table, the logic has to change in some way, you can encapsulate all of that within a stored procedure without affecting applications. Now, not all changes of that type can be done without affecting applications, but a lot of times you can save the hassle of recompiling and deploying multiple applications throughout an enterprise. You can also reduce the complexity of client coding. You're just executing a single statement rather than having to write transact SQL statements that are embedded within an application. And then also, stored procedures divorce the client application from the table structure. Clients don't have to know anything about the database except the input and output structure of the stored procedures that it uses. As a result, database structures can be changed without breaking client code.